Okay, so now we're doing Unit 10 video for our Algebra 2 spring exam in May of 2018. Only a few questions on this one. So this is quadratic modeling. So this is kind of looking at the graphs of quadratics and the equations for quadratics and figuring out how do they apply to real world problems. So first one is we have Abigail, and she tosses a coin off of a bridge. So we can assume, let's say we kind of draw our y and our x-axis. Okay, if we wanted to kind of draw this scenario, we could say the bridge is right here. Okay, and she throws a coin off the bridge. So our leading coefficient for our equation is going to be negative. And we know that because the general nature of this graph is that it points down. Right? If we were to extend this, it would point down like that. The quadratic would look like it's pointing down. So we can automatically cross off B and D because they don't have a negative leading coefficient. And the next thing we look at is the last number, that constant. And we look at, do we want it to be positive or do you want it to be negative? Well, if she's throwing from the height of a bridge, height is not negative. Height is positive. So we know that C is our best answer for number 15. For number 16, on this one, we're looking for which of these satisfy the solution set when the inequality is less than 0. Less than 0 means below the x-axis. Okay, so we'll make a note of that, below the x-axis. So when we're below the x-axis, that's right here at -1 to 2, and it stops at 2. So if we look over here at A, -1 to 2 would be our answer for that. And then number 17, we have an actual model here. So we have a ball is thrown into the air. The path of the ball is represented by the equation. Graph the interval over 0 to 6. So those are our x values. This is what we're going to look for in our table when we put it in our graphing calculator. So let's go ahead and do that, and we're going to graph it here. So if we go to our calculator and we put in negative x squared plus 6x, that's the same thing. If we have t, we can use x instead. And we're going to hit second graph, and it'll take us to our table. And we're going to go ahead and plot 0 through 6 because that's what it told us to plot. So those are the points that we're going to go ahead and put on our graph. So first we have 0, 0, and then we have 1, 5. And then we have 2, 8, 3, 9. And then we go back down, 5, 5, 6, 0. Okay. So it says, what is the ball's maximum height? So if you look here, y is height and x is time. So our highest height that we get is 9 meters. That is the maximum on our graph. What time does the ball reach that maximum height? Well, time is x. If we drop that down at 3 seconds is when it reached 9 meters. In part C, after how many seconds does the ball hit the ground? So if we think about this actual graph and what's going on here, if it starts here, okay, and it goes up, 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 then it comes down, 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 it lands right here at the other x-intercept of 6. So 6 seconds is when it hit the ground. At what height is the ball thrown from? Well, that's your y-intercept. And in this case, our y-intercept is right over here at 0, 0. So we would say 0 meters. Now it says, when will the ball be at least 8 feet above the ground? So if we think about height, that is our y. So we're going to draw a line at 8 on our y-axis. And if we look, okay, if we drop down, 8 is between the x values of 2 and 4. And so let's go ahead and fill in our inequality here. So when we're talking about 8, we're talking about when is when is the ball at least 8 feet above the ground? So when is it this section right up here, that top section? And we would say that's greater than or equal to 8. So we're basically saying, when is the graph above or equal to 8? And that would be from 2 to 4. And we put our equal to's on there because it says at least 8. So it can be 8, but it could be above. If you wanted to write that in interval notation, you could do it like this.